Video, we're going to look at the hydrogenation of 2-methyl-1-butene. Hydrogenation means we are adding hydrogen to the molecule, and in this case it's an alkene. So we're adding molecular hydrogen, which is H2. What we want to do is we want to start by drawing our alkene. Our alkene is 2-methyl-1-butene, so we're going to start by drawing our 4-carbon unit that comprises the butene molecule. We'll start by drawing our line bond structure that represents 4 carbons. 1 carbon on the end and 1 at each vertex. So that's 1, 2, 3, and now number 4. This is an alkene, and the alkene is located at carbon 1. So that means between carbon 1 and carbon 2 we have a double bond, and then our branch is a methyl group at carbon number 2. So that is our starting molecule. We're going to add molecular hydrogen, so we're adding H2, and our reaction will occur and we will make our product. In order to make the product in a hydrogenation, we need to have a catalyst, and that catalyst is a metal catalyst, and in this case we're going to use platinum. And I'm just going to signify that it's a catalyst by saying PT and Cat. So PT is the symbol for platinum, Cat is the catalyst. So we have our starting material, 2-methyl-1-butene. We add hydrogen to it. When we are adding something to an alkene, we're adding hydrogen across the double bond. So at each carbon of the double bond, so I'll number this carbon 1 and carbon 2, at each carbon of the double bond, 1 hydrogen atom goes. We use both of the atoms of the hydrogen molecule. So the result will be that our new product has still 4 carbons, so 1, 2, 3, 4. It has our 2-methyl group, and it will be called 2-methyl-butane because the double bond is now gone. Now what we need to remember, and I'm going to draw the structural formula for this, is what is meant by our line bond structure. So we have our carbon here, double bonded to another carbon, single bonded to a carbon, and then single bonded to our final carbon. We also have a methyl group, so that's single bonded to a methyl group. So now each of these carbons has 4 bonds to it. We'll start with this carbon number 2. There's 1 bond from the double bond, 2 bonds from the double bond, 3 bonds from this carbon, and 4 bonds. This carbon here is done. So this carbon has no hydrogens on it. This carbon right here has 1 bond, 2 bonds, so it has to have 2 other bonds that have hydrogens on it. This on the end has 1 bond, so this carbon will have 3 hydrogens. And this carbon here has 2 bonds from the double bond, so there will be 2 hydrogens attached to it. When the reaction happens, this double bond breaks open, and we have a place for something to bond. And so we put a hydrogen here, and we put a hydrogen here, because this part of the double bond gets broken. And that's what's represented by this structure. There are now 3 hydrogens here, there's 1 hydrogen here, 2 here still, as there were, and 3 here.